A groundhog broke American archaeology. That is not a figure of speech. On the 12th of November 1955, a farmer in western Pennsylvania watched an animal disappear into a hole at the base of a sandstone cliff. Behind it, kicked out into a loose fan of dirt at the foot of the rock, was the soil it had thrown up from below. He crouched down and pushed his hand into the pile. What came up between his fingers was burnt bone. Not fresh bone. Burnt. Somebody had cooked on that spot. He was standing over a fire that had gone out while ice sheets a mile thick were still sitting on Canada. And there was not one archaeologist alive that morning who would have believed him. Because in 1955, every textbook in the United States said the same thing about the deep past of this continent, and it was not offered as a theory. It was the answer. The first human beings in the Americas were the Clovis hunters. They came down out of the north roughly 13,000 years ago, carrying a distinctive fluted spear point, beautifully made, that you can pick up today from Alaska to Florida. And before them, nobody at all. 2 entire continents, not thinly populated, empty. The charcoal at the bottom of that groundhog hole was older. What that farmer had in his hand was 50 years of the ugliest fight in the history of American science. Careers were made and unmade over it. There was a front page of the Washington Post, a laboratory in Oxford, an accusation that a grown man had made the kind of error a first-year student makes, and one geologist who spent 3 decades arguing patiently and in print, not that anybody had lied, but that the ground itself had. And you already think you know how this ends. So did I. Stubborn outsider proved right. Arrogant establishment humiliated, roll credits. It is not that story. The rule that Fire Pit broke is dead. Nobody defends it anymore, not seriously, not in print. But that farmer's own site, its oldest dates were never accepted in 1980, and they are still not accepted this morning. 71 years on, the argument he started is still running. And in the spring of this year, something happened that made me sit back in my chair. The site that actually won this war has just been accused of the exact same crime the Pennsylvania site was accused of, by new researchers, with new methods, in science, in March. 50 years, and the argument has come back around to where it started. So the question tonight is not really was he right. That question is too small, and it is also not answerable in the way you want it to be. The question is this: how does a science actually change its mind? And what does that cost the person who happens to be early? The numbers that came out of that hole are hard to believe, and I will get to them, but the thing to listen hardest for is the other half of it. The reason the establishment was so completely certain that anything older than Clovis had to be wrong. That reason is much better than the story you have been told, and much more uncomfortable, because there is no villain in it. Every man in this fight does his job honestly, under his own name in print. And it still takes 50 years. One of them is 98 years old. He published this year. He's asking the same question he was asking in 1974. By the end you can decide who was right, or whether after all this that is even the right thing to be asking. Chapter 1. The Man Who Filled the Hole. Back in. Let me start with the farmer, because the farmer is not who you think he is. His name was Albert Miller. He was born on the 20th of June 1911, and his family had owned that particular piece of Washington County, Pennsylvania since 1795. Not since the Civil War, since George Washington was president. That is 9 generations of the same people looking at the same hills. The place had a name, Bancroft Farm. He learned to farm from his grandfather, whose methods, he wrote later, were the ones the old man had used in his own youth just after the Civil War. Nothing had changed. Albert Miller grew up on that land with no electricity in the house, no telephone, and no tractor in the barn. Then he lived long enough to watch every single one of those things arrive. I think that matters. I think it explains him. Farming was only part of what he was. He was a naturalist and an outdoorsman who knew that ground the way you know the inside of your own house. He was the local historian, and for decades he worked, quietly and systematically, as an amateur photographer recording rural life in western Pennsylvania. The barns, the tools, the old machines, and the older ways of using them. He did it because he could see it all going. He wrote that he had become enamored of the idea of how old farm buildings and machines and methods might be preserved before they vanished, and that the day would come when demonstrations of the past would fascinate people of all ages. That instinct is the whole of him. A man whose reflex his entire life long was to save the thing before it was gone. There was proof of that on the property already. In the 1920s, a coal company had bought a section of land off Bancroft Farm and mined the coal out from under it. In the 1950s, Albert Miller bought that ground back, worked out and finished with, and started planting trees on it. He planted 300,000 of them. Remember the coal. It comes back later in a way you will not expect. At the edge of the property, there was a sandstone overhang above a creek called Cross Creek, a natural stone awning that projected out from a cliff face about 70 feet high and kept the rain off the ground beneath it. Miller had walked past it his whole life, and he had always half suspected that people must have sheltered under there. It is the obvious place. If you were cold and wet in that valley at any point in the last 10,000 years, that is where you would go. After the groundhog, he went back and started to enlarge the hole. About 12 inches down, in his own words, he realised he was coming up with burnt bone and flint. He found the little sharp waste chips that come off a stone tool when somebody's making it or sharpening it. He found freshwater mussel shells, which meant somebody had been eating out of that creek. And then, at about 30 inches, he found a complete flint knife, 2.5 feet down, in the dirt behind a groundhog, on his own farm. And then Albert Miller did the thing that almost nobody does. He filled the hole back in. Not for the winter, and not for a season while he found somebody to call. He filled it in, kept his mouth shut, and left it alone for 18 years. He was terrified of looters. That is the plain reason. He knew exactly what happens to a site like that once word gets around a county. People come at night with shovels, take the pretty pieces, and destroy everything else in the process, and what is left is a churned mess that can never be read again. So he refused to let anybody put a spade in that ground until he found a professional he trusted. 18 years. He was sitting on the most interesting thing that had been found in that county in 100 years. He knew it. He had the knife in his hand. He could have been in the local paper inside a week, and he told almost nobody, for the better part of 2 decades, because he was more frightened of losing it than he was of being ignored. There is something else in that patience, and the rest of this story keeps proving it. Almost everyone in this account behaves well. The farmer protects the site. When the archaeologist finally turns up, he digs it more carefully than almost any site in North America has ever been dug. And the chief critic criticises honestly on the evidence in the journals without once accusing anybody of dishonesty. Nobody in this story is a crook. There is no grant being protected here, no rival being quietly buried. And it still turns into a 50-year war. Science does sometimes move slowly because scientists are corrupt or captured or afraid. That happens. It is not what happened here. Here it moved slowly for a much worse reason, which is that being careful and being right feel exactly the same from the inside. You cannot tell them apart in the moment. Nobody can. In the spring of 1973, Albert Miller finally found his professional. But before we go down into that trench with them, you need to understand what the two of them were about to walk into, because the rule they were about to break was not arbitrary, and the people defending it were not fools guarding a comfortable little kingdom. They were survivors of something, and that part almost never gets told. Chapter 2. The Cowboy in Wild Horse Arroyo. To explain it, I have to take you back another 50 years, and about 1,500 miles southwest, to a cattle ranch in New Mexico. There was a man there called George McJunkin. He was born into slavery in Midway, Texas, somewhere around 1851. His exact birthday is lost. After emancipation, he went west, and he ended up in the high dry country near the New Mexico and Colorado line, where a black man in that era could find a little more room to move than in Texas. He taught himself to read, and then to play the violin. He read geology and natural history for pleasure, out of curiosity, with no formal schooling behind him at all, and he became the foreman of the Crowfoot Ranch outside a small town called Folsom. On the 27th of August, 1908, a thunderstorm parked itself over Johnson Mesa upstream of Folsom and dropped something like 13 inches of rain in a night. The flash flood came down the valley in the dark and took the town apart. 17 people died, including the telephone operator, who stayed at her switchboard ringing houses to warn them until the water took the building. The next morning, McJunkin saddled up to go and see what the flood had done to the fences. He rode into a gully he had named Wild Horse Arroyo, because that was where he broke horses, and the water had cut the floor of that arroyo down by several feet overnight. Sticking out of the freshly exposed wall, about 10 feet below the old ground surface, were bones, big ones, ribs. He knew cattle, and he knew bison. And he knew immediately that these had come off an animal far too large to have been walking around on that continent in his lifetime. He took a few home, they sat on the mantel in his cabin, and then, for the next 14 years, George McJunkin tried to get somebody to come and look. He wrote to a man in Las Vegas, New Mexico, who had studied mammoth remains. He talked about it to anyone who would listen. He got 2 amateur naturalists interested enough to say they would come out. Nobody came. The site was a 2-day ride on horseback from anywhere that mattered. Almost nobody in that county owned a car, and he was a black cowboy in the American Southwest in 1912, telling people he had found something important. George McJunkin died in a hotel in Folsom in January of 1922, at about 71. He never got anybody to that Royo. Months after his funeral, a blacksmith from Raton named Carl Schwachheim, one of the men McJunkin had talked to, finally talked a banker with an automobile into driving out there. They went in December of 1922, nearly a year after the man who found it was in the ground. They saw the bones and understood at once why he had been so excited. 4 more years went by before anybody carried them to a museum. In 1926, the Colorado Museum of Natural History in Denver identified them as an extinct Ice Age bison and sent a crew. And in the dirt at Folsom, wedged in among the ribs of an animal that had been dead for 10,000 years, they found stone spear points. That detour has a point, and the point arrives now in the form of a man who explains everything that happened to Albert Miller. His name was Alois Hrdlicka. Czech-born, medically trained, he ran the Smithsonian's Division of Physical Anthropology from 1910, which made him about the most powerful figure in American anthropology for the next 30 years. Photographs of him are almost comic in how well he fits the part. Stern face under a heavy moustache, thick hair swept straight back. He looked like authority in a stiff collar, and he behaved like it. Hrdlicka had a position on how long human beings had been in the Americas, and the position was, not long, a few thousand years, 3, maybe 4. He believed correctly, as it turns out, that Native Americans had come from Asia. He simply had the timing catastrophically wrong, and he defended that timing for 30 years with a ferocity that people who lived through it described as intolerable. He was not a fool. He had a reason. The reason was that American archaeology, through the late 19th and early 20th centuries, had made an absolute spectacle of itself over exactly this question. Claim after claim of early man in America was announced with fanfare. A skull here, a hearth there, stone tools in ancient gravels, and one after another, when somebody competent went and looked properly, they collapsed. The stratigraphy turned out to be disturbed. A recent burial had been dug down into an ancient layer, so the bones looked older than they were. The tools were rocks broken by frost or by a river, and in a few cases people had wanted it so badly that they saw what they wanted to see. The discipline had been publicly wrong, over and over, in the same way for decades, and it kept happening after Folsom too. By Adovasio's own count, more than 500 sites across North and South America had been announced as older than Clovis, and every one of them had fallen over. 500. When the 501st came along, nobody in the profession had any reason on earth to expect it would be different. So it built an immune system, and Hrdlicka was the immune system. He reviewed the claims, he tore them apart, and he made it, in the words of one summary of that era, virtually taboo for any archaeologist who wanted a career to argue for deep antiquity in the Americas. He had the standing to end people, and everybody knew it. The uncomfortable part, and this is the assessment of the historians who have gone back over his files rather than mine, is that in every single case he reviewed and rejected before Folsom, he was right. Every one. The claims really were bad. He was a difficult, autocratic, in some respects genuinely unpleasant scientist, and he was also correct about the actual evidence in front of him, right up until the moment he wasn't. When the Folsom point turned up embedded in the ribs of an extinct bison, in undisturbed ground, with independent witnesses called in from other institutions to watch it come out of the wall, the profession moved. Hrdlicka did not. He never accepted it in public, and he went on fighting claims for deep antiquity in America until the day he died. But it stopped mattering. He was wrong about the age of human occupation by roughly 7,000 years, and the evidence was finally clean enough that his objection was no longer the thing deciding the outcome. American archaeology had just discovered deep time on its own continent, and it had discovered it because a self-educated Black Ranch foreman noticed something odd in a flood cut, and spent the last 14 years of his life failing to get anyone to care. Nobody named the spear point after him. Chapter 3. The Clovis Police. That experience does something to a discipline. It does not make it humble. It makes it careful in a very specific and slightly warped way. The lesson the field took from Folsom was not, we should listen to outsiders. The lesson was that extraordinary claims collapse unless the evidence is unimpeachable, and unimpeachable meant this: an artifact that is unquestionably human, in a geological layer that is unquestionably undisturbed, dated by a method that is unquestionably sound. 3 conditions. All 3, every time, or you do not have a site. That is a good standard. It is genuinely a good standard. It is also going to come back later in this story and demolish something you will probably not want demolished. Then, in the 1930s, the second half of the framework fell into place, near a small town in eastern New Mexico called Clovis, at a spot called Blackwater Draw. Underneath the Folsom material, in a lower and therefore older layer, they found a different spear point, larger, heavier. With a distinctive channel, a flute, struck up from the base on both faces so the point could be seated into a split shaft, the Clovis point, and it was associated with mammoth. Over the next 2 decades, as those points were catalogued from Alaska to Mexico to the Atlantic seaboard, and as radiocarbon dating arrived after the war and put real numbers on them, an explanation assembled itself so tidy and so satisfying that it is difficult to blame anybody for believing it. It went like this. During the last glaciation, so much of the world's water was locked up in ice that global sea level dropped by around 400 feet. And when you take 400 feet of water out of the shallow sea between Siberia and Alaska, you do not get a bridge. You get a subcontinent. A grassy, windswept, largely unglaciated landmass 1,000 miles wide joining Asia to America. People walked out onto it, and lived there, and hunted there. But to get south from Alaska into the rest of the Americas, you had to get past the ice, and there was a great deal of ice. 2 enormous sheets, the Laurentide over most of Canada, the Cordilleran over the western mountains, merged for a long time into one impassable barrier. And then, as the world warmed, they began to pull apart. Between them, running north to south through what is now Alberta, a gap opened, the ice-free corridor. Down it came the hunters, spilling out across an empty continent that had never seen a human being, leaving the same fluted spear point everywhere they went, and their descendants populated 2 continents in a few centuries. 1 route, 1 date, 1 toolkit, 3 moving parts that locked together beautifully. It was elegant. It fitted the geology. It fitted the archaeology. It fitted the radiocarbon dates, and it had the enormous psychological advantage of being an answer, in a field that had spent 50 years being humiliated for not having one. By the time Albert Miller was crouching in the dirt behind a groundhog, Clovis First was not a hypothesis in the working sense. It was the frame everything else got fitted into. And by the 1970s, the standard of proof for arguing anything older had crept so high that some archaeologists thought it had become unmeetable in practice. If your site was pre-Clovis, there was, by definition, something wrong with it, and the job was to find out what. The people who enforced that standard called it rigor, and they were not wrong to call it that. The people on the receiving end of it had a different name. They called them the Clovis Police. So when a rock shelter in western Pennsylvania started producing charcoal dates older than Clovis, those dates were not landing on a theory. A theory can be revised over a weekend. They were landing on the discipline's entire immune response, an instinct built out of half a century of being made to look ridiculous. And that reflex did precisely what it had been constructed to do. It just happened this time to be pointed at a site that might have been real. Chapter 4. The Deep Hole. In the spring of 1973, a 29-year-old new faculty member at the University of Pittsburgh was looking for somewhere to run a student field school, somewhere close to home, somewhere quiet, where he could teach undergraduates how to dig without much happening. His name was James Adovasio. He had taken his doctorate at Utah 3 years earlier, and he was already building a reputation in a very unglamorous corner of the field, the study of perishable artifacts, basketry and cordage and textiles, the things that almost never survive. He did not want something spectacular. He wanted somewhere suitable for teaching students the most meticulous excavation techniques there are. A local historian phoned him about a farmer near Avella with a rock shelter on his land. Adovasio drove out. He met Albert Miller, and by all accounts the two of them got on immediately. This young academic and this 61-year-old farmer, who had been guarding a hole in the ground for 18 years waiting for exactly this conversation. Miller showed him the flint knife. Adovasio confirmed what Miller already knew in his bones, that it was prehistoric and that the ground under that overhang had almost certainly not been touched since the people who made it walked away. Miller had found his professional, and the professional had found something considerably more interesting than a teaching exercise. They put the first trowel in the ground on the 15th of June 1973. What happened next is the reason Meadowcroft still matters, and it has nothing to do with the dates. This was not a normal excavation. Adovasio ran that site like a surgical theatre. They worked horizon by horizon, meaning they peeled the deposits off in the natural layers the ground had laid down rather than in arbitrary slices, and they did it with trowels used as if they were scalpels. In the sensitive levels they went further and used razor blades, lifting sediment a fraction of an inch at a time. Every artifact, every flake, every fragment of bone was plotted in 3 dimensions before it was lifted. They screened the fill, floated it for seeds, and mapped the microstratigraphy of the whole trench in coloured pencil, a different colour for every combination of silt and sand and clay. And he did not bring only archaeologists, geologists, paleontologists to read the animal bone, climatologists, and specialists in ancient pollen and seeds. He built a team that could interrogate the sediment itself, because he understood that in a case like this the objects were never going to be the argument. The ground was going to be the argument. Whatever anybody would later say about Meadowcroft, and people said a great deal, almost nobody has ever seriously attacked the quality of that excavation. It became the standard other digs were measured against. It is taught, and they kept going down. The deposits under that overhang were not a couple of feet of dirt with some arrowheads in it. They were stacked like the pages of a book, occupation on occupation on occupation, each one separated by sterile layers of rock spool that had flaked off the ceiling in between and sealed the floor beneath it. 11 natural strata, and within several of them multiple separate living floors, each a surface somebody had actually stood on. By the second summer, the trench, which the crew had started calling the Deep Hole, was down about 10 feet. Then the first radiocarbon results came back from the laboratory at the Smithsonian, while the second season was still in the field. 2 of them landed at roughly 13,000 years, which was already 1,500 years past the wall. On the 4th of August, 1974, the numbers were on the front page of the Washington Post, which, if you know your American history, is a spectacular piece of timing. That was the first week of August 1974. Richard Nixon had 5 days left in office. A piece of charcoal from a Pennsylvania farm briefly pushed the collapse of a presidency sideways on the front page of the paper that had brought it down. Then the scale of what eventually came out of that shelter, because the numbers get skipped over, and they should not be. Around 20,000 artifacts. Stone tools, blades, cores, worked bone, of which perhaps 10,000 matter culturally rather than being waste. Something like 150 separate fire pits stacked through the sequence. One generation building their fire more or less on top of where the last one did, over and over, across thousands of years. 956,000 animal bones. 1.4 million plant remains. In physical terms, that is nearly 1 million individual pieces of bone. 149 different species of animal, each fragment recovered and catalogued out of a hole 10 feet deep and not much bigger than a large room, by people working with hand tools and in the deepest levels with razor blades. That is not a summer project. The main excavation ran 6 years, from 1973 to 1979, and university field schools kept working there into 1989. Though the bone number is misleading if I leave it alone, something over 90% of that animal material is not dinner, it is owl pellets. Birds of prey roosted on that overhang for thousands of years and coughed up the bones of mice and voles and shrews onto the same floor the people were using, which is deflating and also enormously useful, because a continuous record of small mammals through 16,000 years is one of the best climate archives you could ask for. The owls were keeping a weather diary. Nobody asked them to. And down at the bottom, on the 31st of July 1976, they found something that did not belong. A small spear point, lying in place on the uppermost living floor of the lower part of the deepest cultural layer. Lanceolate, which just means leaf-shaped, tapering at both ends, made from local Cross Creek chert, and crucially, unfluted. No channel struck up from the base. It was not a Clovis point, and it was not made the way Clovis points were made. They named it the Miller Lanceolate, after the farmer. He was still alive to see them do it. Around it, out of the same layers, small prismatic blades struck from carefully prepared little cores, worked flakes, bifaces made from cherts that had come from a long way off, from Ohio and from West Virginia. Not one ambiguous rock that might have been a tool if you squinted. A toolkit. Then the chronology, which is the part that mattered, and the part that would be fought over for the next quarter of a century. 52 radiocarbon dates, mostly from charcoal out of the fire pits themselves, and they ran in almost perfect sequence. Oldest at the bottom, youngest at the top, layer after layer older than the one above it, all the way down, with only a few tiny reversals high up that nobody on either side of the fight thought meant anything. That detail is the one that matters, because if a site is disturbed, by water, or by burrowing animals, or by later people digging pits down into earlier levels, the dates scramble. You get an old date sitting on top of a young one, and a scrambled sequence is how you know a site cannot be trusted. Meadowcroft's sequence was not scrambled. It was in order, 52 times in a row. Adovasio's reading of it put the earliest human presence at that rock shelter at around 16,000 years ago, with the deepest charcoal from the lowest cultural features running back toward 19,000. Comfortably, unambiguously, before Clovis, the deepest layer, the one holding the Miller Lanceolate and the blades, has a name in the literature that will come up again. Stratum 2A. When I first went through that sequence properly, I assumed it had to be the end of the argument. 52 dates in stratigraphic order, from hearths, from the most carefully excavated site on the continent, published in the open literature by a man whose technical competence nobody questioned. What could you possibly say to that? As it turns out, quite a lot. And the man who said it did not accuse anybody of lying. He said something considerably more dangerous than that. Chapter 5. The ground lied to them. His name was C. Vance Haynes Jr., and he was, by 1974, probably the most respected geoarchaeologist in the United States. He was born on the 29th of February, 1928, a leap day baby in Spokane, Washington. He trained first as a geologist at the Colorado School of Mines, then took a doctorate at Arizona, and what he did with that combination is the reason his name is on this story. He was among the first people to properly marry geology to archaeology in America, to insist that before you argue about what a site means, you have to understand in detail how the sediment around the artifact got there. He produced the first genuinely reliable dates for both Folsom and Clovis, and he was elected to the National Academy of Sciences in 1990. He had also spent much of his career taking apart claims for early man in the American West. That was, in a real sense, his professional function. He was the person you sent to look at a site that seemed too old, because he could read the dirt. And he read Meadowcroft, and he did not like what he saw. He did not accuse Adovasio of fraud. He never did, not once, in 3 decades. He did not accuse him of sloppiness either, which would have been absurd given the excavation. His argument was stranger and harder to answer than either of those. His argument was that the ground had lied to them. The mechanism sounds like a technicality until you understand it, and then it becomes rather frightening. Radiocarbon dating works because living things take in carbon from their environment, and a tiny fraction of that carbon is radioactive carbon-14, which decays at a known rate. When the organism dies, the clock starts. Measure how much carbon-14 is left, and you know how long ago it died. But there is a catch. After roughly 50,000 years, there is almost none of it left in anything. It has all decayed away, which means carbon from millions of years ago is what is called dead carbon. It contains none at all. Coal is dead carbon. And Western Pennsylvania is coal country, one of the most coal-rich regions on the planet. It is what had been mined out from under Albert Miller's own family farm 50 years before. Now, if even a trace of coal-derived carbon had worked its way into those charcoal samples, whether carried in by groundwater seeping through the sediments, or blown in, or burnt in the hearths themselves by people who picked up a lump of something black and put it on the fire, then the measured carbon-14 in the sample would read artificially low, and low reads as old. Every date at the bottom of that sequence would come back too old, and, importantly, they would all come back too old in a consistent way, which would preserve the beautiful stratigraphic order and make the whole thing look pristine. Haynes put his case in print in 1980, in a paper with a title that tells you exactly how the argument was conducted. He called it Paleo-Indian Charcoal from Meadowcroft Rockshelter. Is contamination a problem? Not an accusation. A question, with a question mark on the end of it. He proposed the skew could be 4,000 to 4,500 years, and he did not try to knock down all 52 dates. The dispute has always been about the 11 deepest, the ones at the bottom of stratum 2A that do the actual damage to Clovis First. Do that arithmetic, and Adovasio's earliest occupation slides forward from 16,000 years ago to somewhere around 11 or 12,000, which puts it inside Clovis, which means Meadowcroft is a perfectly nice, extremely well-excavated site that proves absolutely nothing new. He also noticed something at the other end of the sequence. Some of the dates from the upper levels, on maize, on domesticated corn, looked around 500 years too early for what was known about the spread of agriculture in that region. That is a small thing on its own. But if your dates are systematically running old at the top, where you can check them against independent evidence, that is not a good sign for the ones at the bottom, where you cannot. That was objection 1. Objection 2 was worse, and it had nothing to do with carbon at all. If human beings were sitting under that overhang cooking dinner 16,000 years ago, then those people were roughly 50 miles from the southern edge of an ice sheet, a mile thick. 50 miles. That is an hour on the interstate, so what should have been growing and living around that campfire? Spruce, tundra, cold-adapted species, the kind of country you would see today at the margin of a Greenland glacier. Caribou, maybe. Mammoth. An environment recognisably shaped by the enormous mass of ice sitting just over the horizon. That is not what came out of the deepest layers. What came out was white-tailed deer, squirrel, oak and hickory, a temperate deciduous forest, the kind of woodland that is there now, and the whole of that assemblage is 11 fragments of bone, which almost nobody mentions. Deer, chipmunk, flying squirrel, deer mouse, passenger pigeon, a toad, a snake. You could hold all of it in one hand, and at least 2 of those animals are burrowers who could have worked their way down from a higher layer on their own. That is a thin basis for reconstructing an environment, and you should know it before you decide how much weight the objection carries. It is still the wrong animals in the wrong era, and the question it raises is still fair. As Haynes and his colleague James Mead put it in the literature, over many years and in many forms, it was the wrong world entirely. The site's own interpreters have a response, though I do not think it fully closes the question. The 50-mile figure is the distance to the furthest point the ice ever reached, not the distance to the ice on the day somebody lit that fire. Ice margins move. By the time of the occupation, the front may already have been withdrawing north, which would put the glacier considerably further away and soften the contrast a good deal. That is reasonable. It is not a knockout because the fauna is still warmer than most reconstructions of that region at that date would predict, and nobody has ever fully resolved it. If your site's environmental evidence says warm woodland and your dates say the middle of an ice age, one of those 2 things is wrong, and you had better be able to say which. What stays with me about this exchange is how good the objections were. Most retellings of the story cast Vance Haynes as the villain. He was not. He was doing precisely the job the discipline had built him to do, using the standard Folsom had taught them, in print under his own name, with his reasoning fully exposed so anybody could attack it. That is what the process is supposed to look like. Chapter 6. Yes, Virginia. It really is that old. So the answers, properly, because Adovasio and his colleagues did not simply insist they were right. They went and tested it, for years, and the responses are more substantial than the objections usually get credit for. Their first reply, in 1980, was published under the title, Yes, Virginia, It Really Is That Old. Whatever else you want to say about that fight, nobody was bored. On the coal, there is no coal seam at Meadowcroft. The site is not sitting in or above a coal bed. What is there are isolated outcrops of vitrinite, a component of coal, and vitrinite has a property that matters enormously here. It is not water-soluble. It cannot be dissolved and carried into a hearth by groundwater. It could only get into a sample as visible chunks you could see, and those fragments sit more than a foot of undisturbed deposit away from the occupation floors, and by Adovasio's account are not present in bulk anywhere within 23 feet of the hearths that produce the oldest dates. So they went looking for the particles. Every sample from the Ice Age levels went under optical microscopes and a scanning electron microscope. 4 separate radiocarbon laboratories checked, and so did independent researchers, and no coal particle was ever identified in any of them, on the dating method itself. Samples were sent to the accelerator unit at Oxford, which uses accelerator mass spectrometry, a technique that counts carbon-14 atoms directly rather than waiting to detect their decay. It needs far less material, and it is far more precise. The old dates held on the groundwater. An independent geomorphologist went over the sediments looking for the staining and mineral redistribution that percolating water leaves behind. He found none, and there was one lovely piece of physical evidence for that. Across the floor of the shelter there is a chalky mineral crust, left behind by the dissolution of mollusk shells, and it survives intact. If serious water had been running through those deposits, that crust would have gone. It is a delicate thing, and it is still there. On the association, every single dated sample came out of a fire feature that had unambiguously human material in it. Not from loose sediment, from hearths, with tools and burnt bone, and the whole suite of early dates sits underneath a rockfall of roughly Clovis age. The ceiling came down at some point, sealing everything below it, and that collapse dates to around 12 to 13,000 years ago. So the material under the rubble ought to be older than Clovis, regardless of what you think of any individual radiocarbon measurement. That is a serious set of answers. It is not hand-waving. So the critics came back on the chemistry. When you prepare a charcoal sample for dating, you can separate out different chemical fractions of it, and one of those fractions is the alkali-soluble humates, the dissolved organic acid component. And at Meadowcroft, the humates dated older than the charcoal they came out of, and that is exactly what contamination from outside would look like. Adovasio's people had an answer for that too, and the critics had a response to the answer, and that more or less is where it sat. Answer, counter-answer, answer, counter-answer, across the pages of American antiquity for the better part of 30 years. There was no moment where somebody produced the decisive fact and the other side put their hands up. It ended the way most real scientific fights actually end, which nobody tells you about and which is far less satisfying than the version in the films. Both sides got exhausted, and the field quietly moved on around them. I will not pretend it stayed clean the whole way, or that it left no marks on anybody. Nearly 30 years after that first Washington Post front page, Adovasio published his own account of the whole fight, and reviewers noticed something running through it that he had clearly not troubled to disguise, a real vein of bitterness toward the colleagues who had spent decades treating him as a man who had made a beginner's mistake. He had been right, or very close to right, about the central claim, and he had spent the productive years of his career defending himself instead of building on it. You do not come out of something like that without a bruise. I would not, and neither would you. Chapter 7. The Man Who Decided to Win Slowly. Which brings me to 1990, and to the single strangest decision anybody makes in this entire story. In that year, Adovasio and 2 colleagues, the geologist Jack Donoghue and the radiocarbon specialist Robert Stuckenrath, published a revised chronology for Meadowcroft in American antiquity, and they claimed less than they had before. The new figure was narrow and specific and modest. Native Americans present in southwestern Pennsylvania by roughly 14,000 to 14,500 years ago. That was it. That was the claim they were prepared to defend to the last ditch. On the face of it, that looks like a man losing an argument and quietly walking his position back to save face. It is the opposite. 14,000 years is barely 1,000 years before Clovis. In the sweep of human prehistory, that is nothing, an eye blink, and it sounds so unremarkable a casual reader would skip straight past it. Which is exactly what makes it lethal. Because under the rules as they stood, 1,000 years early and 10,000 years early were the identical crime. Clovis First was not a claim about roughly when people arrived. It was a claim that nobody at all was here before the Clovis hunters. Anybody, anywhere, at any date before 13,000 years ago, breaks it completely. So if Adovasio could hold that narrower line, the rule was still dead. He had simply moved it back onto ground where the coal contamination argument had far less room to work, because now his opponents needed to find only a small skew to be wrong, and a large skew to be right, and the physical evidence for a large skew was thin. He was sitting on the most explosive site in the country, and he deliberately claimed less than he could have claimed. This is my reading rather than something he ever wrote down. He has never, as far as I can find, called the 1990 revision a tactic. But look at the shape of the move. He published a number smaller than the one he had, and that is not what you get from a man chasing a headline. It is what you get from a man who has decided to win slowly. And in that same 1990 paper he allowed himself one line of open defiance. The weight of all the data taken together, he and his co-authors wrote, suggests that this site still represents the best dated evidence for the presence of human beings south of the glacial front in the Americas. Still. In 1990, 16 years into being told he had made a first-year mistake, I have to say the rest of it out loud because this is where most versions of the story start cheating. Even that narrower claim never achieved full consensus. It did not win. The most conservative assessments in the literature still concede only about 12,000 years of occupation at Meadowcroft, and 12,000 years puts it just inside the old rule rather than outside it. In 1999, Adovasio and a colleague published a review of the whole debate, and noted dryly that many once vocal critics had become silent, or bored, or perhaps both. Nobody surrendered. People just stopped writing. There is a number for it. A survey of archaeologists published in 2012, nearly 40 years after the first dates came out of that trench, found around 38% supporting Meadowcroft's early dates and about 20% rejecting them outright, which leaves something like 4 in 10 who, when asked directly, declined to come down on either side. That is not a settled question. That is a room full of experts shrugging. The participants get older. The graduate students who arrive afterwards learn about it as a controversy rather than as a question, and everybody moves along. Meadowcroft did not break Clovis First. Something else did. Thousands of miles to the south, in a bog. Chapter 8. A camp in a Chilean bog. In the mid-1970s in southern Chile, local people showed some visitors an area of eroding creek bank where large bones were coming out of the ground. Word reached an American archaeologist named Tom Dillahay, and from 1977 onward, he and the geologist Mario Pino began to excavate the banks of a small waterway called Chinchihuapi Creek. It came to be called Monte Verde, and Monte Verde was extraordinary for a reason that was not about dates at all. The site had been buried under a peat bog, waterlogged, oxygen-free, the sort of environment where bacteria cannot function and organic material simply stops rotting, which meant that at Monte Verde things survived that almost never survive on an archaeological site of that age. Stone, obviously, but also wood, rope, plant remains, including seaweed carried up from the coast, pieces of hide, wooden stakes, and the frames of tent-like structures, chunks of what appear to be preserved food, mastodon meat and bone, a human footprint in the clay. They were not looking at a scatter of tools. They were looking at a camp, and the seaweed deserves a sentence of its own, because of what it does to the story. Dillahay's team identified 9 different species of marine algae and seaweed at Monte Verde. Some chewed into small quids. Monte Verde is inland. The Pacific is about 36 miles away, and some of those species come from further off than that. Several are still used medicinally in that part of Chile today, and in nutritional terms they are exactly what you would want at the southern end of the world. Iodine, iron, trace minerals, the things that are hard to get from a purely terrestrial diet. So these were not inland hunters who had wandered south down the spine of a continent and stopped. They had a working relationship with the sea, and knowledge of that kind is not acquired in a season, which does not prove how they got to Chile. But a long-standing relationship with a coastline sits comfortably with an arrival down the Pacific margin, and distinctly less comfortably with a long march through the middle of a glaciated continent. That is the sort of detail that does not make headlines, and quietly decides arguments. And when the dates came back, Dillahay's team eventually reported people living at Monte Verde somewhere in the neighbourhood of 14,500 years ago, roughly 1,500 years before Clovis, in the far south of South America. That is a very long way for anybody to walk from Alaska. Dillahay got exactly the same treatment Adovasio had. His own description of the reception is that it was virulent, 2 decades of it. Same arguments in a different accent. The organic material must have been redeposited, the stratigraphy misread, the dates contaminated. And then, in 1997, something happened that almost never happens. A delegation went to Chile, not a review panel reading papers in a conference room in the United States. A group of the field's most senior skeptics, the people whose objections carried the most weight, physically got on airplanes and flew to southern Chile to walk the site. David Meltzer was there, Donald Grayson, Dina Dinkaus, Dennis Stanford of the Smithsonian, researchers from Chile and Colombia, and Vance Haynes, the same Vance Haynes. Same man, different continent, and this time on the other side of the outcome. They walked the ground and looked at the stratigraphy in section. They examined the artifacts. They put their hands in the deposits and satisfied themselves about how those deposits had formed, and then they published a joint paper in American Antiquity conceding that Monte Verde was genuine, that it was archaeological, and that it was older than Clovis. A group of people who had built their professional reputations on a position flew to the other end of the world, examined in person the thing that contradicted them, and then wrote down in a peer-reviewed journal that they had been wrong. That is rare in any field and in any part of human life. It is also the entire reason science works at all, on the occasions when it does. A barrier that had stood for 60 years came down in a single afternoon in a Chilean bog. Nobody was there from Pennsylvania. Meadowcroft did not win. Meadowcroft was never conceded. Nobody flew to Pennsylvania. The rule that had been used to beat Adovasio for 24 years simply stopped existing, because somewhere else, someone had produced a site that was easier to believe, better preserved. Not in coal country, not 50 miles from an ice margin, cleaner. Adovasio was not vindicated. He was made irrelevant, which in some ways is worse, and which the man himself has never entirely stopped being annoyed about. Hold that thought about Monte Verde. All of it. Because I am going to have to come back and take some of it apart. Chapter 9. The coprolites in the cave. Something else started in Chile in 1997, and once you notice it, you see it everywhere in this story afterwards. In the high desert of south-central Oregon, there is a set of shallow caves called the Paisley Caves. They were first investigated in the 1930s by a University of Oregon archaeologist named Luther Cressman, whose claims were dismissed at the time, and I will come back to him at the end because he deserves more than a line. Nearly 70 years later, another University of Oregon archaeologist, Dennis Jenkins, went back into those caves with modern methods, and what he found was, in the most literal sense, unglamorous, human coprolites, ancient, desiccated feces preserved by the extraordinary dryness of the caves, which turns out to be a spectacular thing to find, because feces contain DNA. Eski Villeslev's laboratory in Copenhagen recovered mitochondrial DNA from 2 founding Native American lineages. The results went into Science in 2008, and the radiocarbon dates put the oldest specimens comfortably past 14,000 years. Older than Clovis. Again. And Jenkins got the same reception. Again. Were they really human, or could they be from a dog or a coyote? Could the DNA have leached downward through the sediments from later occupation layers, so that ancient material was carrying modern genetics? Both are fair questions. Both needed answering. So in the autumn of 2009, Dennis Jenkins did the Monte Verde thing on purpose. He invited the skeptics to the caves. He called it an archaeological summit, and he put them at the trench with the sediment in front of them, to ask their questions at the spot where the answers were. Several of them changed their minds standing there. Independent laboratories ran blind tests and confirmed human DNA in the pre-Clovis specimens. And in 2020, a team led by Lisa Marie Chilito at Newcastle closed the last gap without using genetics at all. They used fecal lipid biomarkers, the sterols and bile acids that human digestion leaves behind in a combination other animals do not produce. 3 pre-Clovis coprolites came back unequivocally human, with no DNA involved and no leaching problem to argue about. And the next bit is the one that makes it honest. The same study found that human DNA had in fact been moving through those cave sediments and had turned up inside coprolites that the chemistry showed were not human at all. So the critics were right. Not about the conclusion, about the mechanism. The leaching they had warned about for a decade was real and was producing false positives, and it took a completely different kind of chemistry to get past it. Both things are true at once, and both of them only got established because somebody kept objecting. That is the pattern then. 30 years of letters and journals did not do it. What did it? Twice. Was somebody standing in the hole and saying, "Come here, look at this with me." Chapter 10. One dot in a pattern. Once the wall was down, the evidence that had been piling up quietly behind it for years came through the gap all at once. And something here gets underappreciated, because it explains how these arguments actually work. A single anomalous site is always vulnerable, because you can always propose a special local reason it might be wrong. Coal, or groundwater, or plain bad luck. You do not have to prove the reason. You only have to make it plausible and the site stands alone under a cloud. What you cannot do is propose a different special local reason for 20 sites in 20 different geological settings on 2 continents. So, the map as it stands now, and I will keep this brisk. Cactus Hill in southeastern Virginia, sand dune deposits above the Nottoway River, with blades and quartzite tools beneath the Clovis level. There is Topper, an ancient chert quarry above the Savannah River in South Carolina, and that one is interesting mostly for how it was found. Al Goodyear had been working there since the mid-80s, and like everybody else he stopped digging at about 3 feet down, because 3 feet down was where Clovis was and there was by definition nothing underneath it. Then in 1998, having read about Monte Verde, he went back and kept going, and in the first square he opened, he found worked stone. Topper has since produced far more contentious claims that a great many archaeologists do not accept, and I would not put weight on those. But the moment in 1998 is the useful one. Saltville, also in Virginia, in the valley deposits of an ancient lake bed. Then Page Ladson, which is one of my favourites in this whole business because of where it is. It sits at the bottom of the Orcilla River in Florida, in a bedrock sinkhole, under about 25 feet of water. Divers working in near zero visibility recovered stone tools alongside the remains of a butchered mastodon, including a tusk with cut marks on it, made by somebody removing it from the skull. 71 radiocarbon ages put that occupation at roughly 14,500 years ago. It is underwater because sea level has risen since. Cooper's Ferry sits in western Idaho at the confluence of Rock Creek and the Lower Salmon River. This is Nez Perce land, known to the tribe as the village of Nipehe, which is a reminder that discovered is doing a lot of work in most of these sentences. Lauren Davis of Oregon State first dug there in 1997. He went back a decade later, and the oldest material came in at around 16,000 years, with a set of stemmed projectile points at close to 15,800. No fluting, not Clovis technology, something else, and something earlier. Bluefish Caves, in the northern Yukon, right up at the top of the map, and contested for much the same reasons the next one on this list is. Because in a cave called Chiquihuit in Zacatecas, in northern Mexico, a team reported stone artifacts and dates running back beyond 25,000 years, which would push everything much further still. I will not pretend they are all equally solid. Chiquihuit is heavily contested, and the core objection is one that Lauren Davis, of all people, put about as well as it can be put. Human beings do not hold a monopoly on the physics required to break a rock. Caves fracture stone all by themselves, by frost and rockfall and pressure, and some of what falls out looks worked. That cave has produced none of the other things you would expect from an occupied one. No hearths, no butchered bone. It may be real, it may be a pile of shattered limestone, and anyone who tells you it is settled in either direction is ahead of the evidence. But set aside the weakest of them, and you still have a scatter of sites, from the Yukon to Florida to Idaho to Chile, in wildly different geological settings, dug by different teams with different methods, clustering in a range from roughly 16,000 to 14,000 years ago. Meadowcroft stopped being the outlier. It became one dot in a pattern. Chapter 11. The Footprints at White Sands. And then, in September of 2021, something turned up in New Mexico that made the entire conversation start again. I have covered this before on this channel, and I need to update what I told you, because I would rather correct myself in front of you than leave a wrong thing standing. In the gypsum flats of White Sands National Park there is a dry lake bed. 20,000 years ago it was not dry. It was a large shallow lake, Lake Otero, and around its margins there were wetlands and mud. In 2009, a park scientist noticed tracks eroding out of that surface. A decade later, a team led by Matthew Bennett of Bournemouth University, working with the National Park Service, excavated a locality east of an area called Alkali Flat. they found 61 human footprints, layered through 7 distinct levels of sediment, alongside the tracks of mammoth, giant ground sloth and dire wolf. White Sands is not one discovery. The park holds the largest collection of Ice Age footprints in the world, spread across many separate localities and many separate ages. The 61 prints in that dated sequence are the ones that matter for the argument, but there is another find there, dated far less precisely, that I cannot leave out, because it is the most human thing in this entire story. It is a trackway. It runs for nearly a mile dead straight, out and then back. The prints were made by a woman, or possibly an adolescent male, and on the way out they are asymmetrical, deeper and more slipped on one side, in the way your steps go when you're carrying something heavy on one hip. Every so often the tracks of a toddler appear beside them in a little cluster, and then stop, set the child down, pick the child up, keep going. The pace, the researchers say, is a hurry. Between the trip out and the trip back, 2 animals crossed the line. A mammoth walked over the prints without any apparent interest at all. A giant ground sloth came up to them, reared onto its hind legs, evidently caught the scent, and turned away. On the way back a few hours later, the ground a little drier, the tracks are even and symmetrical, and there is no child. That one is dated only by the animals, by the fact that mammoths and giant sloths were there to walk across it, which puts it at a minimum of about 10,000 years and possibly nearer 13. It is not part of the last glacial maximum evidence, and I am not offering it as such. It is just the single clearest thing anyone has ever recovered about what it was actually like to be a person on that ground. That is not a sight. That is an afternoon. When Bennett's team dated the sediments, using seeds from an aquatic plant called Rupia serosa, spiral ditchgrass, that were lying in the track layers, they got ages between roughly 21,000 and 23,000 years. 23,000 years ago is the last glacial maximum. That is the coldest, iciest moment of the entire last glaciation. The ice-free corridor was not open. It was not partly open. The 2 ice sheets were fully merged and the interior route did not exist. The announcement went off like a bomb, and the criticism arrived immediately. And when I covered this the first time I told you the dating was genuinely contested, which was then the honest position, the reason is Rupia itself. It is an aquatic plant. It lives submerged, and submerged plants take their carbon from the water they sit in, not from the atmosphere. If that water is fed by springs running through ancient limestone, it carries dissolved carbon that has been out of contact with the air for a very long time. The plant takes that old carbon into its tissue while it is alive, and so it can be dated far older than it is on the day it dies. It is called a reservoir effect. It is real, it is well documented, and an aquatic plant in a spring-fed basin in limestone country is close to the textbook case for it. That was a completely fair objection, and it will not surprise you who made it in print. In 2022, in the journal Paleo America, Vance Haynes argued that the evidence for humans at White Sands during the last glacial maximum could actually be evidence for Clovis people about 13,000 years ago. He questioned both the ages and the way the track-bearing layers had formed. He was 94 when he wrote it. He is 98 now, a Regents Professor Emeritus at Arizona, and still active in the School of Anthropology. 70 years after he started, the same man is standing at the same post, asking the same question. Are you certain the ground is telling you what you think it is telling you? I find I cannot bring myself to be annoyed at that. I think it might be admirable, so the White Sands people went back, twice. In 2023, researchers led by Jeff Pagati and Kathleen Springer of the United States Geological Survey published in Science, and they had gone at the problem from 2 completely independent directions. First, they radiocarbon dated terrestrial pollen from exactly the same layers as the Rupia seeds. Conifer pollen sorted out of the sediment in enormous quantities by a technique borrowed from cell biology. Land plants take their carbon from the air, so there is no reservoir problem by definition. If the pollen agreed with the seeds, the objection collapses. Second, they used optically stimulated luminescence on quartz grains from within the footprint-bearing sequence. That method does not involve carbon in any form. It measures how long it has been since a mineral grain last saw sunlight, from the trapped electron energy built up in its crystal structure while it sat in the dark. 2 clocks, running on completely unrelated physics. Both agreed with the seeds. The luminescence results were statistically indistinguishable from the radiocarbon. And then in June of 2025, in Science Advances, a team led by Vance Holliday at Arizona, with a doctoral student named Jason Windingstad, went at it a third way. They left the footprints alone entirely. They dug fresh trenches through the old lake beds and dated the organic mud itself, the sediment the tracks were pressed into, at a laboratory that had not handled the earlier material. The mud came back at between 20,700 and 22,400 years old. 3 different materials now: seeds, pollen and mud. 3 different laboratories, 2 separate research groups, 55 radiocarbon dates, all telling the same story. Holliday's own summary of it is the line I keep coming back to. It would be serendipity in the extreme, he said, to have all these dates giving you a consistent picture that is in error. One caution: Holliday is not a stranger to White Sands. He did geology there in 2012, and he is a co-author on the original 2021 paper. This is not a hostile outside team confirming a rival's result. It is the same question asked 3 times, of 3 substances with 3 completely different ways of going wrong. Not everybody is convinced even now. Michael Waters at Texas A&M, one of the most careful people working on this question, remains unpersuaded. And there is one criticism the dating cannot touch, which Windingstad himself put plainly. This is a trackway, not a settlement. Nobody has found the camp. If people were walking around the Tularosa Basin 22,000 years ago, where did they live? And why has nothing else of theirs ever turned up in a region archaeologists have picked over for a century? That is a real hole, and it is honest to say so. But my reading is that genuinely contested has moved a long way toward probably right, and I owed you that correction. Chapter 12. The corridor that opened. Too late. Which leaves an obvious problem. If people were standing on a lakeshore in New Mexico 22,000 years ago, how on earth did they get there? Because the corridor was shut. That is not in dispute. At the last glacial maximum, the 2 ice sheets were fused, and even after they began to separate, what opened between them was not a pleasant walk. It was a chain of cold meltwater lakes, bare scoured rock and dead ground with nothing to eat in it. The ice pulled apart somewhere around 15 to 14,000 years ago. But physically open and actually usable are different things, and in 2016, a team led by Esker Villerslev and Mikkel Pedersen measured the difference. They took sediment cores from former lake beds in the narrowest part of the corridor and read the ancient DNA and pollen preserved in them, layer by layer, to work out when anything living had actually arrived. The answer was about 12,600 years ago. Before that, the deepest layers were, in Pedersen's description, bare. No steppe grass, no bison, no mammoth, and critically no wood, which for a hunter-gatherer walking a 1,000-mile passage is not an inconvenience, it is a death sentence. Steppe vegetation and the animals that eat it only show up at around 12,600, followed by open forest much later. That is a genuinely awkward number, because Clovis is older than it. 12,600 years ago, there were already people all over the continent south of the ice. A separate study working from the DNA of ancient bison put the route properly traversable by around 13,000, which is earlier, and still not enough earlier to rescue the model. So the corridor, the thing that was in every textbook diagram for 50 years, with a neat arrow drawn down it, appears to have opened too late to have been the route for anybody, including the Clovis hunters it was invented to explain. The corridor cannot be the answer for anybody who was already here. Chapter 13. Sunrise Girl Child. This is where a completely different line of evidence walks in, one that never goes near a trench, and which has quietly become one of the most powerful constraints on the whole question. Genetics. In 2013, at a site called Upward Sun River in the Tanana River Valley in interior Alaska, archaeologists excavated a burial containing 2 infants, both girls. One was somewhere between 6 and 12 weeks old. The other had died before birth. They had been buried together with grave goods beneath a hearth. The names given to them in Middle Tanana Athabascan are Sunrise Girl Child and Dawn Twilight Girl Child. The burial dates to around 11,500 years ago, and in 2018 her full genome was published in Nature. What it showed, nobody expected. She's closely related to Native Americans, but she does not sit inside any known Native American group. She sits basal to all of them, meaning her lineage branched off from the ancestors of every other Native American population, before those populations diverged from each other. She represented an entire people that nobody had known existed. They are now called the ancient Beringians, and by reading how much genetic difference had accumulated between her lineage and everybody else's, and running that backwards against known mutation rates, geneticists could estimate when the branches split. Sunrise Girl Child's people split off from the rest somewhere around 20,900 years ago. And the two great branches of Native American ancestry, the northern and the southern, separated from each other somewhere in the region of 15,700 years ago, though that figure moves around depending on whose analysis you read. Treat these as estimates with real error bars, not dates on a calendar. Trace what that implies. There is a period of thousands of years during which the ancestors of every Native American alive today were genetically isolated, cut off from Asia, not mixing with Siberian populations anymore, not yet in the main body of the Americas either, or at least not identifiably so. Where were they? The favoured answer is Beringia itself, not the strait, the drowned subcontinent. The idea is called the Beringian standstill. A population moved out onto that vast exposed plain. The worst of the glaciation closed in around them, and they stayed. For thousands of years. In a refuge of shrub tundra and scattered wood along the southern margin, isolated from everybody, slowly accumulating the genetic signatures that all Native Americans carry, and that appear nowhere in Asia, not even in Siberia. That is a model rather than an observation. Nobody has excavated a standstill camp, and the plain where it is supposed to have happened is under the Bering Sea. What we have is a pattern of genetic distance that needs a period of isolation to explain it, and Beringia fits the requirement best. On that reading, this is not a migration at all, it is a marooning, and then, as the ice began to give, they came south. One other thing worth knowing came out of Montana. In 1968, at a site called Anzik, construction workers uncovered the burial of a small boy, about a year old, covered in red ochre and buried with more than 100 stone and antler artifacts, including Clovis points. He dates to roughly 12,700 years ago, and he is the only Clovis-associated human burial ever found. His genome, sequenced in 2014, links directly to the southern branch of Native American ancestry, and most indigenous populations of Central and South America descend from a group closely related to him, which kills a certain kind of story. The Clovis people were not a separate wave of colonists who replaced somebody. They were part of the same family as everybody else in this hemisphere. Whoever was at Meadowcroft, and whoever left those footprints at White Sands, and whoever built the huts at Monte Verde, and the Clovis hunters, and the Nez Perce, and the people of the Tanana Valley, are all branches of one arrival, or at most a very small number of closely related ones. The Anzik child, incidentally, was reburied by local Native American tribes in 2014 on the hillside where he had been found after the analysis was complete and with their agreement. That was not a small thing either. So the genetics and the archaeology have converged on a shared picture, though they still argue about the edges. Long isolation in the north, a southward movement as conditions permitted, and an interior route that was almost certainly not available for the earliest of it, which leaves the coast. Chapter 14. The Kelp Highway. The leading model now, and it has moved from heresy to orthodoxy inside about 25 years, is that the first people came down the Pacific margin, along the edge, by boat and on foot, hugging a coastline that ran from Northeast Asia around the rim of the North Pacific, past Beringia, down the outer edge of the ice, and into the Americas below the glacial front. The version of it with the best name and the best supporting logic was proposed in 2007 by John Erlandson and a group of colleagues, several of them marine ecologists rather than archaeologists, which is the reason it is good. They pointed out that if you follow that coastline, you are following kelp. Kelp forests grow in cold, shallow, rocky coastal water, and they run in a near-continuous belt from Japan up around the Pacific Rim and down the west coast of the Americas as far as Baja California. And a kelp forest is not scenery. It is a food factory. It concentrates fish, shellfish, sea urchins, seals, sea otters, seabirds. It also damps down wave energy, which makes a small boat far safer, and it gives you something to tie to. The people making that trip would never have been far from food. No mountain range to cross, no winter in the interior of a glaciated continent, and the ecosystem barely changes over that entire distance, so people who knew how to live on one stretch of it already knew how to live on all of it. No new skills required, just keep going. Erlandson called it the Kelp Highway. That is a particular kind of argument, though. Nobody dug that up. It is an ecological argument, built from where kelp forests grow and what lives in them and what a small boat can do, and it says the route was possible and attractive, not that anybody took it. On present evidence, it is the best available explanation for how people got south of the ice before the interior opened. But the difference between the best available explanation and a demonstrated fact is exactly the distance this whole story has been arguing about for 70 years, and I am not going to collapse it for you now, especially since the hypothesis has one deeply inconvenient feature. Sea level was around 400 feet lower during the glaciation, so the entire route those people travelled, every beach they camped on, every shell midden they left, every hearth, is now underwater, offshore on the drowned continental shelf, in some cases many miles out and hundreds of feet down. The coastal migration hypothesis has a structural problem that no amount of cleverness fixes. The evidence for the coastal migration is at the bottom of the sea. Erlandson has described the continental shelves as one of the last frontiers for archaeology, and he does not mean it loosely. There are teams working on it right now, and I will tell you what that work actually looks like at the end of this, because it is where I think the answer eventually comes from. Though it is worth saying that Page Ladson, in the sinkhole under the Orcilla River, was found underwater. Divers recovered the butchered mastodon tusk. It worked once. Chapter 15. The Atlantic that never was. One thing that happened after the wall came down belongs in this story rather than in a footnote. When a barrier of that size falls, a great deal rushes into the gap. Some of it is careful work, some of it is not, and the field learned, fairly painfully, that the establishment was wrong once, is a sentence that can be used to justify almost anything. Dennis Stanford was one of the delegation that flew to Chile in 1997 and put his name on the concession paper. Curator of North American archaeology at the Smithsonian, an enormously respected figure, and by every account a generous man and a superb field archaeologist. Beginning in the late 1990s and fully developed in a 2012 book written with Bruce Bradley of the University of Exeter, Stanford proposed something quite different from the coastal Pacific model. He proposed the Atlantic. The Solitrean hypothesis, as it is called, ran roughly as follows. The Clovis point is a technically demanding object, and skill sets like that do not appear from nowhere. They are inherited. So where is the ancestor of Clovis technology? Their answer was Europe. The Solutrean culture of Ice Age France and Spain, whose nappers produced extraordinarily fine bifacial work, including the famous laurel leaf points. Solutrean people, they proposed, hunted along the edge of the North Atlantic sea ice, and followed that ice edge west, living on seals and seabirds the way Inuit hunters did in historical times, until they reached North America. Their evidence was a laurel leaf-shaped blade netted off the mid-Atlantic seabed by a fisherman in 1974, alongside a mastodon tusk dated to nearly 23,000 years, and a mitochondrial DNA lineage carried by some Native American populations, haplogroup X2A, which is not common in Siberia. Stanford was a serious person, and it was not proposed in bad faith. It is also, at this point, rejected by the overwhelming majority of archaeologists and geneticists. On the tools, comparative studies did not support the connection. Bifacial thinning is a solution to a problem that arises independently wherever people make thin stone blades, and there is a gap of several thousand years between the end of the Solitrean and the appearance of Clovis, with nothing in between. On the genetics, which was always the strongest sounding part of the argument, the case did not hold. Haplogroup X2A is roughly the same age in the Americas as the other founding lineages, A, B, C and D. If it had arrived separately from Europe in a later crossing, it would be younger. It is not. And the oldest X2A lineage found in the Americas comes from an individual known to the scientific literature as Kenuic man, and to the tribes of the Columbia Plateau as the Ancient One, who lived about 9,000 years ago on the west coast, which is the wrong side of the continent entirely for an Atlantic arrival. His entire genome has been sequenced. It shows no European ancestry at all. There is no scenario in which a person inherits his mitochondrial DNA from Solitreans in Iberia and every other part of his genome from Beringians. And then there is the part that is not about evidence. The Solitrean hypothesis was picked up, enthusiastically, by white nationalist groups who used it to argue that Europeans were in the Americas first and that indigenous claims to deep ancestry and to land, and to the moral weight that comes with being the first people of a place, are therefore weaker than everyone thinks. That was not what Stanford and Bradley intended. They objected to the association, and Bradley has pushed back hard on the suggestion that the science was racially motivated, arguing that misuse by fringe groups is not an argument against a hypothesis. He has a point about the logic. A bad idea's fans do not make it wrong, but it does sit inside a very long tradition, and that tradition has a name. It is the same one that gave us the mound builder myth in the 19th century, the elaborate and entirely fabricated notion that the great earthworks of the Ohio and Mississippi valleys were built by some vanished race of old world colonists rather than by the ancestors of the native people who were being removed from that land at the time. That story was popular for a reason. It was useful. Dennis Stanford died on the 24th of April 2019 at 75. The hypothesis has not been rehabilitated since. That is the cautionary note. When a rule of that size falls, the space it leaves does not get filled by clear thinking. It gets filled by whatever was waiting outside, and some of what was waiting outside had nothing to do with archaeology at all. Chapter 16. Who was here? First is a legal question. Something has been circling this whole account, and it is time to say it plainly. There is a habit in the way this subject gets told, and I have probably fallen into it myself tonight, of calling the Americas before Clovis empty, and of calling every one of these sites discovered. Cooper's Ferry was not discovered in 1997. It is Nipehi. The Nez Perce lived there for generations and knew perfectly well it was an ancient village because it was theirs. The Paisley Caves sit in the territory of the Klamath and Modoc peoples. Meadowcroft sits in country that was home to Monongahela and later Shawnee, Delaware and Seneca people, who left the shelter around the time of the Revolutionary War, which is a polite way of describing what actually happened to them. And the question that every one of these sites is trying to answer, who was here first, is not an abstract question in the United States. It has a legal edge on it. It always has. The Kennewick case is the clearest illustration. In 1996, a skeleton eroded out of the bank of the Columbia River in Washington state, about 9,000 years old, and it became the centre of a long and bitter fight between scientists who wanted to study it and 5 tribes of the Columbia Plateau who regarded it as an ancestor and wanted it reburied. Vance Haynes was among those who worked to keep it available for research, and the scientists largely won that round in court. Then, in 2015, full genome sequencing showed conclusively that the ancient one was more closely related to modern Native Americans, including the tribes who had claimed him, than to any other population on Earth. He was repatriated and reburied in 2017 by members of those tribes at an undisclosed location. I'm not going to tell you what to think about that because reasonable people disagree and it is genuinely difficult. There is a real loss when a unique record of the human past goes back into the ground and cannot be asked further questions. There is also a real wrong in treating somebody's ancestors as specimens because the law lets you. What I will say is that the scientific answer, when it finally arrived, said the tribes had been right, not out of politeness, out of the genome. And the Anzac child, the Clovis boy in Montana, was studied with the involvement of local tribes and reburied afterwards, which suggests the field learned something. Chapter 17. March 2026. So, the present, and the reason I said at the start that I did not expect to be putting this in a script. Monte Verde is the foundation under the entire pre-Clovis edifice. Every textbook chapter on the peopling of the Americas written since the year 2000 has it in there. On the 19th of March, 2026, a team led by Todd Suravel of the University of Wyoming, working with colleagues in Chile and Austria and at the United States Geological Survey, published a paper in Science arguing that Monte Verde is between 4,200 and 8,200 years old. Not 14,500, 4 to 8. That puts it inside the Clovis era, and then thousands of years past it in the Middle Holocene, at a point in prehistory when there is no controversy at all about whether people were in South America, because obviously they were. Their argument turns on 2 things. The first is a layer of volcanic ash. There is a well-known tephra in that part of Patagonia called the Lepue tephra, laid down by an eruption of the Mission Mahuida volcano about 11,000 years ago, and Suravel's team report identifying it in sections along the creek at Monte Verde. Their reading is that erosion cut a channel through the area, and that the occupation actually sits on top of the ash rather than beneath it. If that is correct, it is decisive because nothing above a layer of ash can be older than the ash. The eruption sets a flaw. Everything on top of it is younger, full stop. The second is redeposition. They argue that the wood and other organic material at Monte Verde, the material that produced those famous ancient dates, was not deposited by the people who used the site. It was washed down into lower sediment layers by the creek. Old wood moved by water, coming to rest in a level it did not belong to, and then dated as though it did. And I want to be fair about the strength of that, because their own new radiocarbon results on wood and charcoal from around the site came back between roughly 13,400 and 16,500 years, entirely in line with the previous work. They are not saying the old dates are wrong as measurements. They are saying the dates are on the wrong objects. Dating the wood, as they put it, does not date the occupation, any more than dating the stone an axe is made from tells you when somebody made the axe. You have been listening to me for a long time now, so I suspect you can already hear what is happening. Because that argument is not new. That argument is 50 years old. The ground lied to them. Old carbon in the wrong layer. The site is not what it appears to be, not because anybody was dishonest, but because a natural process moved material around, and the excavators read the result as an occupation. That is Vance Haynes' argument against Meadowcroft in Spanish half a century later, aimed at the site that beat it. Surrevel knew exactly what he had done. He said, before publication, that this site has been incredibly important for 30 years, that the interpretation of Monte Verde as one of the oldest sites in the Americas has become a universally accepted fact, and that he expected the work to be impactful and also controversial. He got that much right. The first reactions, within days, were brutal. Michael Waters at Texas A&M, who is nobody's idea of a soft touch on early sites, and is himself a skeptic about white sands, called it egregiously poor geological work. David Meltzer, who had been on that plane to Chile in 1997, pointed out that the sampling had not been done at the Monte Verde site itself. John Erlandson, the Kelp Highwayman, allowed that some old wood might well have been redeposited by the creek, but said the authors cannot demonstrate that the ash lies directly beneath what Dillahay's team actually excavated. His verdict was 3 words: "I'm not convinced." And Dillahay, who is now at Vanderbilt and who has been working at that site since 1977, promised a proper answer. It arrived on the 4th and 5th of May. 30 researchers, 3 separate letters in Science. With their supplementary material, they run to more than 100 pages. The first is led by Dillahay himself, with the geologist Mario Pino and 16 others. Their central claim is not that Surrevel misread the ash. It is that the ash is not there. There is no 11,000-year-old Lepui tephra beneath the Monte Verde site at all, they write. What Surrevel's team sampled is a different layer entirely, and they make the practical objection too, which lands harder than any of the geochemistry. After limited hours across 4 days in the field, they write, with no excavation at all, Surrevel's team proposed that the site dates to the mid-Holocene. They did not dig inside the original site, so they could not study its stratigraphy, or how the artifacts sat in the ground, or the features around them. The second is led by Waters, with Halligan of Page Ladson, Davis of Cooper's Ferry and Holiday of White Sands, blunter. The study offers no evidence that any of the dated wood or bone was ever moved at all, they say, and the stratigraphy it describes is not the stratigraphy of Monte Verde. The third is led by Meltzer, with Villerslev and Pedersen and others from the genetics side, and it makes the argument that no amount of geology at one creek in Chile can touch. If Monte Verde is 8,000 years old, the genomes still say people were south of the ice long before Clovis. The northern and southern Native American branches had already separated from each other by around 15,700 years ago, and they could not have separated if there was nobody down there to separate. I said earlier that almost everybody in this story behaves well. That held for 70 years, and it did not entirely hold this spring. One researcher accused Surrevel's group of being driven 100% by ideological bias, and noted that he had published in 2022 arguing that people arrived late. Which is true, and it settles nothing, because holding a prior position is not a scandal. It is a description of every scientist who ever lived, including Dillahay, who has given nearly 50 years to this one site. But both men walked in already holding a view, and you should know that. Surrevel's own response to 100 pages of criticism was almost cheerful. When more than 30 authors write 3 separate letters about your paper, he said, it underscores the significance of the research. He sees little in them that raises serious concern. The exchange was still running in June. I am not qualified to adjudicate that, and neither is anyone who is not standing in that creek bed with a trowel. Survival may be right, and a generation of textbooks needs rewriting. He may be wrong in exactly the way Haynes was wrong about Meadowcroft, which is to say intelligently, on the evidence, in a way that takes another 20 years to unpick. What I can tell you is this. 71 years after a groundhog kicked burnt bone out of a hole in Pennsylvania, the argument that hole started is still going. Not as history, not as a settled chapter with a moral at the end. It is going right now, in the current issue of the journals, between living people who are annoyed with each other. And there is one name on that first letter that stopped me when I found it. Among the 18 authors defending Monte Verde, about 2/3 of the way down the list, in among the geologists and the palynologists, is J. Adovasio. He is 82 years old. Monte Verde is the site that walked past him. It is the site that got the delegation and the concession paper and the textbook chapter, while his own dates were left under a cloud where they have sat ever since. Nobody ever flew to Pennsylvania for him, and when somebody came for Monte Verde with an argument about redeposited material and contaminated context, which is the precise argument that was used to keep him out in the cold for a quarter of a century, he signed his name to the letter defending it. I've thought about that more than any other detail in this story. You can read it as professional solidarity, or as a man defending the whole pre-Clovis edifice, because his own site is one of the bricks in it. Both of those are probably true. But there is a third reading, which is simply that he recognised the argument, from the inside, having had it done to him, and he did not think it was right this time either. And nobody has done the one thing that worked last time. Nobody has flown to Chile, not one delegation, not one afternoon standing in the section together. It has been letters, 100 pages of letters, which is exactly how the last one went, and the last one took 30 years. Chapter 18. Where it stands tonight. So the honest state of the argument, as of tonight, runs like this. Clovis First is finished. Not the soft version, the strong one. The version that says the continent was empty until 13,000 years ago. The version that was in every textbook in 1955 and most of them in 1985. That version is gone and it is not coming back. And even if Survival is completely right about Monte Verde, it does not come back because there are 20 other sites and there is the genome. People were in the Americas thousands of years before Clovis. They very probably came down the Pacific coast rather than through the middle of the ice, because when the earliest of them arrived, the middle of the ice was not passable. Their ancestors seem to have spent thousands of years isolated somewhere in the north before that, long enough to become genetically distinct from everyone they had left behind, and the best physical evidence of how they actually travelled is sitting under 400 feet of ocean on a drowned shelf where almost nobody can dig. That is roughly the shape of it, and nearly every part of that sentence is still argued about at the edges by people with real credentials and real reasons, and Meadowcroft? Still argued about. Its oldest dates have never been fully conceded, and nobody ever drove out to a vela, stood in the deep hole and said out loud, in print, with their name on it, that James Adovasio had been right all along. The site is still there. It was designated a National Historic Landmark in 2005, the highest historic designation the United States gives, and you can go and see it. It is enclosed now under a permanent structure, with a walkway that takes you out over the excavation, so you can look down into the stratigraphy itself and see the layers stacked in the wall of the trench. The ones nearest your feet hold people who were there when Rome was standing. The ones at the bottom hold a fire that was lit while there was ice on Canada. Vance Haynes is still in Arizona. When last written about in the professional literature he was, in among the Paleo-Indian research, preparing a publication on 1875 pattern officers' rifles, a weapon that has fascinated him since he was a boy. That is such a specific and contented thing to be doing at 98 that I keep coming back to it. Those two men have been on opposite sides of this since Gerald Ford was president. Both are still here, both published this year. Chapter 19. Albert Miller lived to see it. But the person I actually want to end on is the farmer, because I nearly got this part wrong, and the correct version is a great deal better. I had it in my head, from an earlier account, that Albert Miller died before any of it resolved. That he went into the ground with his sight still under a cloud the way McJunkin did. That would have been a tidy ending. Grim, but tidy. The kind of ending that makes a good short video and a bad piece of history. It is not true. Albert Miller lived to see it. He was 86 in the summer of 1997, when the delegation walked into that bog in southern Chile. He was still alive when they published the concession, and Clovis First stopped being the rule. He died of heart failure in late January of 1999 at 87, and his obituary in the Pittsburgh Post-Gazette described him as a conservationist, a historian, and a co-founder of Meadowcroft. 44 years. That is the distance from a man crouching in a groundhog spoil heap in 1955, with a piece of burnt bone between his fingers and no idea what to do about it, to a discipline finally arriving at the position he had been standing in the whole time. He was there for the whole walk. And he did not spend those 44 years waiting. That is the other thing about him. In between the discovery and the vindication that was never quite a vindication, Albert Miller was building. That worked out coal ground he bought back off the company in the 50s and planted with 300,000 trees. In 1959, he and his brother Delvin opened a youth camp on it. Then the brothers began moving old buildings onto the site. Meadowcroft Village opened to the public in 1969, 4 years before Adovasio ever drove out there, with around 20 rural buildings from the 1800s, a log church, a one-room school, a covered bridge. Precisely the project that had been forming in his head since he was a young man watching the old farm machinery go to rust. Later came a recreated indigenous village, and eventually the Rockshelter itself. There is a small irony in that ground, and I will let you enjoy it without labouring the point. The museum that grew up around the most famous coal contamination argument in American archaeology is standing on land a coal company mined out and abandoned. So for the last quarter century of his life, this man was running a museum on his own farm about the deep past of a site whose deep past a substantial fraction of professional American archaeology did not accept. He never got the paper. There was no letter, no retraction, no colloquium where somebody stood up and said Albert Miller and Jim Adovasio were right and we were wrong. He got something rarer than that, and I think possibly better. He got to be old, and still there, and still going out to that shelter, on the day the rule that said he could not be right stopped existing, set him beside McJunkin, because between the two of them you have the whole thing. Both men found something in a hole that the ground had opened by accident, a flood in one case and an animal in the other, and both understood at once that it mattered. Neither had any training. They were amateurs, self-taught, entirely outside the professional structure of the science they were about to disrupt, and exactly the sort of people that structure had learned to ignore. One of them died in January, alone in a hotel, 14 years into trying and failing to get a single person to come and look. The other died in January too, 77 years later, having spent 44 years watching a discipline slowly walk toward him. The difference between those two endings is not evidence, and it is not talent. Albert Miller happened to live a very long time. That is all of it. It is a very uncomfortable thing to build a happy ending on. So let me push on it, because there is a third man in this, and I have only mentioned him in passing. Luther Cressman. He was an archaeologist at the University of Oregon, and in the 1930s he was digging in the Paisley Caves. The same caves the better part of 70 years before Dennis Jenkins found the coprolites. Cressman found human material in the same deposits as the bones of extinct Pleistocene animals, and in 1940 he reported that people had been in that basin at the end of the Ice Age. He was dismissed for insufficient documentation. His stratigraphic recording was not detailed enough, by the standards the field was developing, and without airtight documentation of the association between the human material and the animal bone, the claim could not stand. By the rules of the time, that was a defensible decision. It may even have been the correct one on the information available, and it took nearly 70 years, and an entirely new suite of techniques that did not exist in 1940, for somebody to go back into those caves and demonstrate that Luther Cressman had been reading the ground correctly the whole time. He did not live to see it either. So now you have three of them. Cressman, dismissed in 1940 and confirmed 60 years later. McJunkin, ignored until he was dead. Miller doubted for 44 years and alive at the end of it by what amounts to actuarial good fortune. And every one of those cases was handled at the time according to the correct procedure by competent people applying a reasonable standard. That is the thing I cannot get past. Chapter 20. What the field actually learned. Because the field did learn, and what it learned is more interesting than they stopped being stubborn. What emerged from these 50 years is a genuinely good standard for what counts as a valid early site. You need artifacts that are unambiguously the work of human hands, not stones that might have been broken by a person. They have to sit in a context that can be demonstrated rather than assumed to be undisturbed. The dates have to come off material with a direct physical relationship to the human activity, not off something lying nearby. And increasingly you need more than one dating method, running on unrelated physics, because a single method can share a systematic error with itself all day long. You can watch it work. Challenge the White Sands dates and nobody argues with you. They go and find a different material and date that instead. Say the Paisley DNA might have leached and somebody comes back at you through fat chemistry, with no DNA in it at all. The response to a charge of contamination is not indignation anymore. It is to go and reach the same conclusion by a route where that particular contamination cannot apply. Vance Haynes, of all people, taught them that. His objection to Meadowcroft was not answered by anybody shouting. It was answered by Oxford, and by a geomorphologist, and by a mineral crust, and by a rockfall. He made the field better by being difficult. That is not nothing. If you wanted to know how alive this argument still is, you would not have to look very hard. In October of 2026, the people in this story, and the generation behind them, gather in Santa Fe for the Paleo-American Odyssey Conference, the largest of its kind since 2013. The program is already published, and it reads like an inventory of everything I have just described. Lauren Davis on Cooper's Ferry, Dennis Jenkins on the Paisley Caves, a paper from a team in Alberta titled simply The Mythical Corridor. Esk Willerslev opens it on the Thursday with a talk called What We Know About the Peopling of the Americas. David Meltzer closes it on the Saturday with one called What We Still Don't Know. Same three authors on both papers. I do not think that is an accident. And on the Friday morning at 8:30, Tom Dillahay speaks on what the people crossing into South America carried with them. At 9, in the same room, Mario Pino, the geologist who's been reading the creek bed with him since 1977, gives a talk on the geology of the Monte Verde area. 5.5 hours later, in the same room after lunch, Todd Suravel gives a talk about a Clovis site in Wyoming. I would pay money to be in that room. I suspect the coffee break is where the actual conference happens. So the honest answer to who got here first is that we do not know, and that the leading edge of the question has moved from 13,000 years to somewhere between 16 and 23,000, and that the difference between those two numbers is the difference between a story about walking and a story about boats. What would actually settle it is a site on the old coast, a hearth, or a shell midden, or a scatter of stone tools with a date on them, sitting on a drowned beach off British Columbia, or Alaska or California, under 300 feet of water. They are looking. There are survey vessels out there right now running acoustic pulses down through the seabed to map buried river channels and old shorelines under the mud, working from models of where a person would have chosen to camp when that shelf was dry land. It is the least romantic archaeology imaginable. A boat, a winch, a computer screen and years of nothing. And it might be where this ends. Not in a trench with a delegation of experts standing around the edge of it agreeing with each other, in a core sample, pulled up out of the dark off a research vessel by somebody who was not born when Albert Miller died. I would like to be here for it. I suspect some of you would too. Chapter 21. What was actually in that shelter. There is one thing I have not done in the whole of this though, and it has been nagging at me. I have spent this entire time talking about dates, radiocarbon, luminescence, humates, reservoir effects, stratigraphic order. I have talked about the argument. I have barely said a word about the people. Let me put that right, because the arguing is not actually the point, and it would be a shame to finish without saying what was in that shelter. Start with the shape of the deposit. More than 20 distinct occupation layers stacked through 14,000 years at the very least. That is not one group of people. That is thousands of separate visits, across a span of time so long that the ice sheets melted and the forests changed and the animals changed and the languages changed several times over. And the one constant is that when human beings walked up that creek and it started to rain, they went under the same rock. Every major cultural stage of Eastern North America appears in that sequence, which is arguably a more remarkable fact than the age of the bottom layer, because it means you can read the whole thing as a single document. And the people at the bottom of it left a very particular kind of trace. The stone waste in the deepest levels is dominated by the sort of flakes you get from the final stages of shaping a tool and from maintaining a kit you already have. Resharpening, repairing, touching up an edge. That is what you leave behind when you are not settling in. It is what people leave when they are moving through, carrying finished equipment, stopping for a night or two out of the weather and going on, which is inference rather than fact. But it suggests they were not living there. They were passing through. The Miller lanceolate is not unique to the shelter either. Surveys across the Cross Creek watershed turned up other lanceolate points of the same kind, along with small prismatic blades and the little cores they were struck from. A coherent toolkit, across a whole valley system rather than at a single spot, and it has a name now. The Miller Complex. So whoever these people were, there were enough of them, moving around that country for long enough, to leave a recognisable signature across a whole watershed. Not one lost family passing through once, and then the enormous mass of everyday material above them. Deer, mostly from the later levels, squirrel, turkey, fish. The freshwater mussels that Albert Miller pulled out of the Groundhog spoil on day one, which people had been carrying up from the creek and eating in that shelter for thousands of years. Seeds, nuts, charred fragments, hickory and walnut and acorn. Somebody sitting under that overhang cracking nuts and throwing the shells into the fire, and the fire going out, and the ceiling flaking a little more rock down over the ash. And 400 years later, somebody else doing exactly the same thing 18 inches higher up. 150 fire pits, not one great hearth. 150 separate occasions, at least, when somebody thought, here, this is the spot, and built a fire in more or less the same place their great-great-grandparents had. The last of them left around the time of the American Revolution. That is what is actually in the ground at Meadowcroft. Not a controversy. A very long, very ordinary, entirely human habit of getting out of the rain, repeated for something on the order of 500 generations. The argument about the bottom 2 feet of it will presumably go on for another 30 years. But I do not want you to walk away with only the argument, because Albert Miller did not guard that ground for 18 years to win a dispute in a journal. He guarded it because he understood, on the day he found the knife, that people had been there, and that if he was not careful, the record of them would be scattered and sold and lost, the way the old barns and the old machines and the old methods had been going all his life. He was doing what he had always done. He was saving the thing before it was gone. Chapter 22. The 2 readings. So what do we do with all of it? I have gone back and forth for weeks, and I still land in 2 places depending on the day, so I am going to give you both. The first reading is that this is science working, slowly, painfully, with the wrong people winning for decades at a time and honest people paying for it out of their own careers, but self-correcting in the end, by evidence, in the open, in print, where anyone could check the working. Nobody had to be exposed as a fraud because nobody was won. The skeptics were right to be hard to convince. They were simply hard to convince for about 20 years too long. And when the evidence finally became good enough, they got on a plane, went to look, and wrote down that they had been mistaken. Whatever happens to Monte Verde now, that afternoon happened, and men and women with reputations to lose did it in public. If that is your reading, then this is a story about a system that works, and the 50 years of pain is just what the system costs. The second reading is darker, and it is the one that keeps me up. The rule was worse than wrong. It stopped people from looking. That is a different kind of damage, and it does not show up in any of the papers. If every textbook says the continent was empty before 13,000 years ago, then nobody applies for funding to dig into the layer underneath. Nobody sinks a trench past the level where the answer is supposed to stop. Field seasons are short and money is thin, and there is always a reason to close the excavation at the depth where the known material ends. Why would you keep going into sterile ground? That is what happened at Topper. Goodyear dug below the standard depth at which Clovis sites had previously been excavated, not because of a new technique or a new theory, because he decided to keep going past the point where the textbook said the record stopped. And there was something there. The uncomfortable implication of that sentence is not really about Topper at all. If the only thing standing between a site and never being found is somebody choosing to put the trowel in 6 inches lower, then the depth at which a discipline believes history begins is also, in a very literal sense, the depth at which it stops looking. So the question is not how many Meadowcrofts were argued about and eventually won. The question is how many were never argued about at all. How many were covered back over, quietly, by somebody who did not have Albert Miller's patience or his 18 years or his 87, who found something in a bank or a burrow or a drainage ditch, mentioned it once to somebody who told them it could not be that old, and let it go. That number is not 0. It cannot be 0. And somewhere out there right now, under a field, under a road, under a parking lot, under somebody's backyard, the next one is sitting there in the dark, exactly where it has been for 16,000 years, waiting for something to dig in precisely the right place. Maybe a groundhog. So tell me which of those two you land on and why. I'm not being polite when I say that. The comment section on the last one of these was better than the video was, and I read all of them, and I would rather have your argument than my own. And if this earned the time you gave it, the like button and the subscribe button are how I find out that it did. They are small things. They are also the entire reason I get to keep doing this. There is another one on this channel about what happened to the Clovis world at the end, about the 12,800-year event and the fight over what caused it, and one of the men in tonight's story turns up in that one wearing a completely different hat. That is the one to watch next. It picks up exactly where this one stops. One last thing. The staff at Meadowcroft gave the groundhog a name. They call him Rocky. There is a stuffed one in the visitor centre in a museum t-shirt with a name tag that gives his job title as on-site archaeologist. And as far as I am concerned, he is the closest thing American archaeology has to a patron saint. An animal who cracked open the biggest question on the continent entirely by accident, dug his hole, kicked the evidence out behind him, and never once looked back to see what he had thrown away. Keep your minds open, and until we meet again.